All right, so this is chapter 10, one of our math chapters, and chemical quantities involves things such as the moles, things called empirical formulas, percent composition, and some topics like that. A lot of it is review. The first part of the PowerPoint, first slide, is entirely review. You guys know what a mole is at this point. 6.02 times 10 to the 23rd. Atoms, molecules, or dogs, it doesn't matter what it is. Avogadro's or avocado's number, as we fondly know it. 1 mole of any element equals its AMU, its atomic mass number. And for example, 1 mole of carbon is 12 grams. And then finally, if you're trying to figure out the molar mass of a compound like carbon dioxide, you add up all of the individual atoms that are used to make up that compound. CO2, everybody kind of remember that CO2 is 44 grams, because we're going to use that a lot today as we go through.
That was on a worksheet.
Yep. Exactly. That's why we're about to use it a lot. All right, so that's all review. The mole. Mole and atom ratios. Any?
I just wanted to get it.
Okay. Anytime you need to know how many atoms are in something, if you figure out how many moles you have and then multiply by Avogadro's number, then you can figure out how many atoms you have. So our first sample question, C12 has a mass of 6 grams. How many atoms do we have? So, Nick?
6. That's
6
3.
grams.
3. You got? I don't know.
Our math looks like this. I'm going to give you 6 grams of carbon 12. We go to our poster, its AMU is 12. So we have 0.5 moles. Then we would multiply that times Avogadro's number. So, and the result being 3.01 times 10 to the 23rd.
I had my PowerPoint.
Those are the steps. That's all right. It's all
I
good.
don't know where it's at. I just had it.
Are you PowerPoint-less at the moment?
Yeah.
All right,
I
that's,
have to print some off real quick.
I've got one more right here.
Like, I swear I had
It's all good. It's all good. All right. So here are the steps typed out. 6 divided by 12, half a mole, and then half times Avogadro's number gives us our result. Again, this is all review. You guys have already been tested on this several times. You'll be tested on it more times. All right, the new constant that you've got to have memorized. And you tackled the worksheet the other day on Thursday. 1 mole of any gas at standard temperature and pressure is 22.4 liters of volume. Liters are volume. And at standard temperature and pressure, which is 101 kPa in metric, or 0 degrees Celsius, you have a volume of 22.4 liters. Imagine, anybody get the Costco cases of water? It's a 40-pack of half-liter bottles. It's a little bit more than that as far as the mass is concerned. All right, using this, you can calculate various mole quantities of gases or volume quantities, etc. So let's start with this question. 3-liter jar at STP, how many moles of gas do we have? So we're going to set up a ratio. I'm going to give you 3 liters. And 1 mole is equal to 22.4. So could I get someone to do that math for me real quick?
67.5.
3 divided by 22.4.
I knew I was doing it right.
I don't know it.
You
I mean,
said
can I
you put
get on
something
my
else
phone?
on that sheet, and I told him.
I got
I
it.
knew.
I got it.
It's all good.
He's got it.
3 divided by 22.4
Oh, 3.
is.
0.1339.
No, it's 0.11339. She's right. I'm wrong.
And what is it?
0.1339287. Yeah. So 34.
0.134 moles. And that's as complicated as that gets. All right, the more complicated version of this is when we give you grams and we've got to figure out moles. So I'm going to give you 88 grams of CO2, 88 grams. And how much did we say a
44.
mole of CO2 was?
44.
44. 44 grams per mole. And so how many moles do I have?
2.045.
Let's go with 2 even. Go with 2 even. Any rounding issues there? And so if I have 2.0 moles, how many liters do I have?
44.8.
44.8. It's 22.4 times 2 are 2 moles. 44.8 liters. All right, so momentarily, after we talk about one more type of calculation, we'll go over that Thursday's worksheet. Thursday's worksheet. All right, next slide. It's a pretty short PowerPoint, but one of our most complicated concepts is something called percent composition. How much percent of a given compound, potassium dichromate in this case, and what's the percent of each of the 3 compounds, 3 atoms that make up that compound. So here's our step. Again, another 2-stepper. First thing we do is calculate how many grams we have of each of the constituents in here. So we know this process. What is this? What's half of that? 39. So 1 mole of potassium all by itself is 39 grams. We have 2 atoms, so we've got 78 grams worth of that. Chromium is 52. We have 2 of those. Total of 104. And then 7 oxygens is 112. Get our molar mass of K2Cr2O7. Total mass is 294 grams per mole. Sorry. All right. Once we have our final mass for a mole, then we do ratios of each of the 3 constituents, of the 3 elements. Our potassium was 78 out of the 294. So there is our math for that one. Our chromium is 104 over 294. And then we would multiply this times 100%. And then finally our last one, oxygen, as you can see, is our heaviest component. And we've got 112 grams of that in over our 294 times 100%. And these are our 3% that we wind up with. You can double check yourself by adding them all up. They should come to 100. So those are the
super duper.
It is super duper. So that's the steps, the 2-step process of percent comp. We'll practice that in a few minutes. Then finally, something called an empirical formula. Tomorrow we'll do a worksheet on this. Empirical formulas.
Isn't that like the,
What's that?
no.
No, sorry. Empirical formulas. Here we have glucose. Here's the formula for glucose. C6H12O6. Sometimes chemists want to know the basic ratio of the elements. Not how many there are, but just their relationship to one another in terms of a ratio. And we look for a lowest common denominator in the quantities of the elements that are there, the atoms. We see that 6 is the lowest common denominator, so I'm going to divide everything here by 6.
We're almost done.
And we're going to wind up with C1H2O6, O1. And we don't write the ones, as you guys know by now. And so our empirical formula for glucose is CH2O. CH2O down here. All right, so more practice on that tomorrow. It's not used often, but you do need to know how to do it. All right, that is our
Yes.
chapter 10.
That's our notes for the day, and it's cut off right on time. And you cut it off, I guess.